My name is Max-Gerd Retzlaff, and I'm happy to talk to you today. I would like to demonstrate uLisp to you and show you how you can make embedded systems with it, or IoT devices, which are connected systems for the so-called Internet of Things. It's hard for me to give a presentation to an audience that I don't know so well, so let me ask you 2-3 quick questions. First, show of hands, who has heard about uLisp? Oh, aside from the call for papers for this conference. Who has used it? Oh, 3 even. And who has used Lisp on an embedded system? Or a small computer? Any Lisp? Or 2? Oh. Who has used Lisp on any embedded system? Or any computer before, say, 1995? Ah, okay. Mobile phones are basically supercomputers of 20 years ago. And when you take an embedded system of today, like this one, the square inch, or this one, I would call it a computer. So the specification, it's a dual-core processor, 32 bits, 240 megahertz. RAM is a bit scarce, but it has flash, Wi-Fi, Bluetooth, USB. This one has a screen with a resolution that might remind you of DOS, though with more colors. It has a SD card slot. You can put 8 gigabytes into it. So it has a screen, speaker, microphone. So it's a computer, I would say. And the smaller one is basically the same, just without a screen. It has an RGB LED instead. So basically, it's a computer. So often you don't need a Raspberry Pi, I would say. And I show you here the M5 stack. I'm not from the company. I just like the housing. There are so many companies to choose from, Adafruit and many, many, many. Even like these, even cheaper. Or if that's too expensive, if you need something for a lot of customers want to ship it, there's a predecessor, the ESP8266. You can buy them for less than €2 on a PCB. So that is OK. Now we need something to program it. I programmed them since around 2003, I would say. I used assembler and C and Arduino sometimes, Forth and ColorForth. But then there came uLisp, and I was really curious. It took a while until I started, a good year ago. And uLisp is of David Jones Davis. He sends you his regards. He has been here before, so he sent me a picture to show to you. And I actually, when I started to use uLisp, and I was more and more, I liked it more and more, I noticed I used software by him before. So when I did my supplementary topic for my studies at design school, I used Identifont to identify fonts. And it is by him. One of the largest, independent directories of typefaces is by him. One of a tool for converting handwriting is by him. This identity tree, the most recent from 2015, is by him. I show you all these because they are all written in Common Lisp. They all based on CL-HTTP. The primer is also by David and runs also on CL-HTTP. So a lot of Common Lisp. But let's talk about uLisp now. uLisp is actually pronounced uLisp. I pronounced this microLisp. He corrected me. I found online that many people discussed, no, it needs to be microLisp. It's a small u, like microcontroller. It's not. It's uLisp. And uLisp is the Lisp for microcontrollers, and is specifically designed for scarce memory. So the first one was an Atmega 328 with 2 kilobytes of RAM, and that's few. There's now even a variant of it. It's uLisp 0. Doesn't need 0 memory, but only 1 kilobyte of memory. And the uLisp runs on 8-bit up to 64-bit platforms now, which would be the RISC-V ones. And uLisp is an interpreter. It's not a compiler. It's tail-optimized, so recursive functions are efficient. It has a garbage collector, a simple mark and sweep, which is fast enough even on the smaller devices. And uLisp itself is a language. David says it's a Common Lisp subset. So everything that runs in uLisp should also run in Common Lisp. But there's one important difference. It's a Lisp 1, so only one namespace. And when you're like me, your variables are called list and string. Sometimes you get problems. But then again, a map is a bit nicer, I think. So we know that David knows a lot of common Lisp. Why is it not a common Lisp? So he sent me this. This was his original objective, he explained to me. So it's a Lisp for people that want to program hardware and want something more powerful than C. And the last line says it's not for experienced common Lisp programmers, because they can, if they really need a common Lisp, they take a Raspberry Pi, they have Clojure common Lisp, they have everything they need. This is supposed to be a Lisp for newbies. Still, it's really powerful. There are also other Lisp for the ESP. There's ESP Lisp, which looks really nice with an embedded Emacs and interactive debugger. I haven't tried it. What is so good about uLisp? Sorry, one slide I have missed. Differences between common Lisp and uLisp. So one I told you already. Another one is no macros. Users added to it, but the basic uLisp doesn't have macros. There's no multiple values. There's either one value or no value, which is nothing, a special symbol, but no multiple values. He says use a list like in Clojure if you want multiple values. There's no destruction bind, and because there's no macros, you cannot just easily add it. And there's no condition system, or even not exception. So you have a function error, stops everything, gives you back to the top level. So no loop you can do, you are back to the top level. That's not a problem for many people programming embedded systems, because they usually have a watchdog, and if something hangs for 2 seconds, it's just everything is restarted and it's good again. It's not good if you do networking. If you do networking and something runs off and you try to reconnect, that's a lot of overhead. But there's a user who added at least ignore errors, and I extended a bit so that you actually know what the error was. So that's for me, it's good enough. And one last difference, if you program it, the first time I used it, I tried, it doesn't work. It breaks all the time. And that is because the semicolon doesn't end at the end of the line, but as the next open parenthesis. And that is because the Arduino terminal works like this. It doesn't send a new line. So this is one of the things where David decided it's important that it runs for newbies. So what's really good about uLisp is really the documentation. The documentation is really great. You go to the web page, also in Common Lisp, of course, and on the left side, you see a menu. And this menu goes down and down. So if I unfolded it, it looks like this. And it's getting started. It's tutorials. It's references. So the language reference with all the description of the extension, the implementation details. If you want to know how the garbage collector works, how you extend it with C, everything is documented. The platforms are described from 8 to 64 bits. There's assembler for 3 platforms. So actually, if you have assembler already, the step is not too far to a compiled Lisp maybe. Because right now you can just enter inline assembly, and that will make you the machine code. And then there's examples, simple examples, larger examples, standalone devices, games. So the documentation is really great. And if that's not enough, there's a forum, which is quite active. So a lot of people asking questions or just saying, hey, I missed macros, I added them. And if that's not enough, there's also the GitHub. So this is the uLisp ESP repository, and it has 28 forks, and mine is one of them because I optimized that for this platform. So that was the introduction, I hope. Let's come to the demo. And before I continue here, I need to reassemble. And you can look how you connect to it. So it's basically, you connect to it via a serial terminal, because it includes a USB port and a serial terminal, so you can connect on Linux with the screen, and on macOS you have also installed it, and I use Emacs. Can you see everything okay? Yes. I switch to Emacs now. Is that okay? And I would connect one of those computers. And as I described here, I connect to it with meta, colon, and then the function. And I reboot it, so you see how it reboots. So it's uLisp, and you have a REPL. You can type something in, 23, I need my sheet. You can add Oh, yes, of course. You can add, you can define a function, you can call the function, you can look at the function, you can save an image, you can reboot. I need to abort because otherwise it boots something. And then I see that the function foo doesn't exist, and I can load image, and then we have our, it was called fun. Fun is again there. So then you have devices. You want to talk to things. So let's do that. We look at implementation of buttons. So this device has 3 buttons, and I can just define that button 1 is on pin 39. I can initialize the buttons, and then I can check here if the button is pressed. It's not. I press it, and that's it. And then you see here digital read. This reads the pin, the button. You can replace it with analog read, and you can read analog devices. So an example would be here a pH sensor. It is not connected right now, but it would be here analog read of pin 35. I have to calculate because it's 3.3 volts and it's 12 bits, so I do this little computation, and let's load it, and we get raw pH voltage, and that's a random value. Usually analog devices have really a lot of noise. You should at least read repeatedly or have a running average. I do it here and get PHV, but does it 64 times and would be more stable if I had connected a device, of course. We can do a calibration, so we say that 1.8 volts is pH 4, 1.38 is pH 7, can do a simple linear interpolation, and we would get something like get pH, which would give us a pH value of an analog device. So that's easy enough. The next would be if you have something more complicated, like this one. It's a temperature sensor with a one-wire bus. The one-wire bus needs just one pin and ground and VCC voltage. And you can connect to one pin 128 of such devices. There's a library for that, so I extended it with C. And I hope you see it. I will not go through everything. Basically, I define where it is, which library I use, and then to extend uLisp, you have to extend the enum function with your symbols, init temp, get temp, some more. Define your C code. This would be a Lisp function defined in C, so it's init temp that takes 2 arguments, 2 objects, args and env, and returns an object. And then you would need to tell uLisp what the Lisp name is, init-temp or get-temp, and add it to a lookup table down here, basically telling this function has this name and has so many arguments. So let's try it. Init temp finds my sensor with the address. Get temp gives an error because it needs the address. And we have a temperature. So the next would be I have this little device. I bought it actually quite long before I started with uLisp, never used it, as a keyboard. So let's connect this one. So it's again, is it big enough?
No.
Better?
Okay.
So the keyboard is called a Faces keyboard for some reason. And the library looks like this. This, you know already, is just a digital read, because every time I press a button, it tells on a pin, hey, there's a new key. But the first line is new. It's an address. And then, let's add this first. And then there is keyboard pressed, which would tell you if a button is pressed. So I press a G and tells me, oh, there was a button. I can use raw read keyboard, and it will tell me a number. I can add a tiny bit more, and it would be read keyboard, which does some checking and does decoding, tells me no button. I press H, and it tells me H. So this was enough to make this. You see it already. It's a standalone Lisp computer for my nephew to learn a bit of programming. I sent a little relay to him so he can control. He builds all these devices with pumps and ventilators, so I thought he can learn a bit of programming. Too fast. The same way, I extended it to talk to a GPS sensor. That would be this one. And added a display to it. Looks like this. I have it on slides. Because what it is a GPS-based speedometer and clock for my motor scooter. Because this motor scooter has always a clock and it's always broken because the battery is hard to replace. So I disassembled the motor scooter, added this little Lisp device, disassembled the clock, added the OLED display, connected those old buttons, that's bottom left, and put it back in so I have no better speedometer and clock, which is nice. The next thing that would be quite interesting, I connect the other again and look at the time. I always do this 3-finger salute because it just gives me gets me to the REPL quickly. The next would be network. So I need to peek in my notes. I connect to a Wi-Fi. Please don't connect to this Wi-Fi because you might disturb my presentation. It's my own special Wi-Fi, and it ought to work. Sorry for that. So it's connected to Wi-Fi now, and we can use function for that. So one example would be here on the left, a web client. It talks to uLisp.com, puts a bit of HTTP, so let's call it web client, and it downloads the web page of uLisp.com and shows it to you. The other direction is almost as easy. You start a Wi-Fi server. You define a really simple web server, like this one. You need to start it. And where was the IP again?
You start a Lisp server. You did not start a Lisp server, start a web server. Lisp server?
I wanted to start a web server.
And a Lisp server?
It's something else. No. Maybe my notebook is not connected. Oh, it's awfully slow. I don't know. Maybe I didn't start it properly. I would ask you to let me continue. It basically is just a web client, and that would send a web page back and then the current time. And you saw quickly how it is supposed to look. I don't know why it doesn't work now. But starting with that, I thought I need more network. So I extended it a bit to have a proper HTTP command like curl. So I want to talk to REST servers. I want get, post, put, authentication, certificates. So I implemented that. And the next would be an example how to use it. So it's HTTP, an address. I need to stop it. You stop it with the tilde letter. So that sometimes you have to repeat. Yeah. And let's try that. Yeah. Actually, that is what I made in the plane over here. I forgot the presentation device. So I took one of those and a battery. And the battery is empty. Oh, it boots, connects. I'm shaking a bit. Let's try. Oh, it doesn't want to talk. Something is wrong with the network right now. I don't know why. But the whole implementation of it is this here. The send next, it just connects to a server, and then a simple loop. to sense it. And on the server side, I have just a little bash that would send the next character. When I call it here, it seems to work. So every time I enter, I go, whoop, page down. So that's networking. With the networking and time and Wi-Fi, you could already talk to a database. So I'm here privately or on my own, but I work for Dydra, which James Anderson works for it. I work for him, I have to say. And we have Dydra as a database, so let's talk to it. It's a triple database, implements the graph store protocol, so that would be the HTTP call to it. Graph store put. It works. And you see on the left, maybe not too good, it sends a triple of button pressed and a time, unparses this and triple, sends to the server, and gets back here n triples. I could also parse it. And this actually uses a garbage collector, you saw quickly. And you can make it more nice. Did I make an error? Nope. So this would decode what is sent to the server. That was a server reply. I could have a graph store get to retrieve from the server, and it would give me again triple result. So I copy this one to actually pass the result and show me what it stored. So at quite current time, which I stored a moment ago. So that is networking. And with that, I did my first sensor device a year ago. Oh, you can also use it from Android when you directly connect it to your mobile phone when you're in an airplane, for example. And the first application was this one. It was this cheap pH sensor. It was this water sensor. It's connected to it, and the application looks like this. It's on this or this computer. The first thing, it loads the source code from the network, runs the application. You see that is how the application looks, a really simple GUI in its time and the temperature sensor. Then you can download the latest calibration from the server, select what the solution is under test, and you can measure it. And this is how the measuring looks. We store it to Dydra, which is this triple store that I use. And I added this slide. We often, datagenous is sort of the research part of Dydra. And we use notebooks to look at our data. So James Anderson implemented a library that you can, in a notebook, to talk to the server, and then you can import that library and download results and visualize in a notebook. So I need to continue. One thing is, this one was just a special device for one location or two locations in Stuttgart and in Berlin and Germany. But what is when you have such a device, you ship it to a customer, needs to connect to the Wi-Fi, so you have a problem. If you cannot ask, hey, send me the password, I install it to you, you need to do what's called provisioning. So you need to provision that device with information. So let's do that. I connect this. No. It's every time, that's the third time it fits. Ah, that works. Okay, so I booted. It has a blue LED, means doesn't have any Wi-Fi. It tells you even So it waits for provisioning. So let's do that. And so here's my mobile phone. I say I want to. What?
Is this your real mobile phone?
Yeah, it's here.
And the time there is correct?
What is correct?
The time.
Oh, sorry. Yeah. I click on it and it looks for Wi-Fi. Sorry for that. I click next.
The time is correct.
It might be. It might be.
It might be a little over, and that's okay.
Okay. I'm sorry for that. It looks for networks. It finds my falafel network. I click on it. I enter the password, which I copy to save time. It connects. And this should scroll down here. Might be more interesting. Provisioning successful. It boots. The green LED means it connects to Wi-Fi. When it stops, it's connected. So this is now connected to Wi-Fi. So in it, NTP and get time should work. So it has network. That is how I provision now. And with that, I made my second bigger device, which I shipped for. Yeah.
Quick interruption.
The second last page.
No, your time is up, but everyone is very curious. So officially, everyone go and have a coffee. And when I raise my hands, everyone can jump on your desk.
Okay.
Okay? So please carry on.
Okay. This is the biggest sensor device I shipped for a guy in Dubai. And I cannot tell too many details. It uses 10 environmental sensors for control of power sockets, to control pumps and light and all that. Has Wi-Fi provisioning, talks to REST backend with JSON and HTTPS and certificates, and has a JSON protocol based on relaxing schemas, sends sensor readings to a backend, and then there is a smartphone application that another party developed to control the actors and calibrate the more complicated sensors. And it uses C code for the temperature, and all the others I implement completely in uLisp with the I2C protocol. And I would like you to join doing uLisp, and these are not that expensive. So I got 10 of them and put this uLisp on it. You are free to try or share or pass it around and join me in having the fun.
Maybe we should run an auction.
No. I'm not a manufacturer. No. Thank you. No. Just.
Any questions? Where is the please?
Fascinating stuff. That last one you showed to the person in Dubai, what was the total cost for that? Approximately? Total cost of the slide, approximately.
Yeah. How expensive was this device in total?
For controlling illegal consumption of alcohol.
You mean for the hardware or including my work?
Including everything.
No, that I cannot tell. The hardware, it's, I told you this one costs 10 euros, but it's the cheapest component. There are quite accurate sensors in it. So what I call the cheap pH sensor costs maybe 80 euros, and the one I used here costs 2 or 3 times as much, but has 100 times the accuracy. But it's really a completely separate system that you need to talk to and configure, so that's more work. In total, the hardware, what's 2 prototypes, so hardware costs, I don't know, 500 euros or something, but adding to my work. There's a fun fact, if someone asks about, does someone ask about this? Is there a question?
What's that?
That is a keyboard connected here, and it uses an Atmega 328, so you can also run uLisp already on that one, and not just use it as a keyboard. I didn't do that yet.
Any more questions?
Yeah.
I was very interested in seeing that you're talking about Bluetooth Low Energy, because a lot of sensors use that nowadays, like bicycle sensors, for instance, speed sensors, cadence, speed.
Yeah.
Are those kind of things also available using uLisp?
Low power devices, or?
What was the question?
The question is about using uLisp in such devices.
In low power devices, or
to measure rotations and metal strain and that kind of stuff.
Well, you can add. If the question is, I didn't understand the question completely. I have to admit.
Well, if there is a general, okay, let me simplify.
Are you asking whether performance is sufficient for measuring bike speed? Is that what you're asking?
Yes, for instance.
Can you use this for real time, like checking?
Well, I measure the speed of my motor scooter. That works fast enough.
Gyroscopes, accelerometers.
Yes, yes, yes. I have. If you want to play with it, I have here dozens of sensors with me for infrared and a lot of, or connect other devices, control servos, LEDs. So you can connect to a lot of it. Yes, please. And low power, that is something I try. So just before the conference, I got such a solar panel. And I want to try to run the web server, actually, of DevSystemNet, the company. I want to run it on such a device with low power, but that's to be done.
So we have two questions from online. The first question is there a detailed description of any of the amazing devices from the presentation somewhere? How can I build one?
Partly.
So the question was about reproducibility.
Yes, where is the stuff? I showed you already that I have a GitHub account for my fork of it, and many of the things here are included that are written in C, and then I still have my old private weblog running on Arenada with CL Block. I don't know, in a clicky is written that no one uses CL Block, I do. And I describe extensions that I do here, and also part of the Lisp code. But in the last months, I just worked a lot of it, and I have no backlog of things that I need to add.
Another person online wants to know, is the code available online?
Well, all the C code and the uLisp code, my extensions are in my GitHub already, GitHub account already in Git, and documented in my wiki, in my blog. I don't write in the forum, but there are 2 people that write when I post something in the forum now. That's nice. I have not everything published, but if you are interested, you can also write me to info@devsystemnet.
Okay, and there was another question. Have you tried implementing any REPL-driven environment with completion, structural editing, etc.? No, I have not. For that, there is, I mentioned it already, I think it was called ESP-Lisp. I found it, I have not tested it, but it looks mighty interesting. It runs only on the ESP32, if I remember correctly. Oh no, the smaller variant as well, the ESP8266. And that is also a Lisp for the ESP32, and it includes a small Emacs. It has a really nice REPL, it seems. I only look at the pictures, like you. It has a debugger, and this is one of the projects I wanted to look at more closely. But uLisp has a really simple line editor. If you liked Ed or Edlin, you would like it as well. I do it with Emacs like this. But as I said, the uLisp has a really plus point. If you like Common Lisp, you like documentation and specification, and that is really a great job. Yeah, from David Jones Davis.
Any more questions?
Thank you.